Hi, class. Thank you for your patience earlier this week. I wanted to go through the solutions and the data manipulation exercise a little bit more slowly, particularly now that I have working audio. Uh, and I think it would be good just to articulate a little bit more as to why data manipulation is useful and helpful. So first, what we're going to do is we're going to start from scratch and upload this data set. So we're going to go to CSV, look in downloads, and upload our scores variable. And the thing that I want to mention that I was doing a lot of that is really helpful when you're doing a long set of procedures is that this paste option will keep a record of exactly what you do. And so instead of having to memorize what I did and write up a handbook or a set of notes, I can just have a program log of all of the manipulations I ran and then run this play button at the very end. Now, the data set that we're working with has a few distinct issues that we're going to need to address. One is we have a household income variable that we'd like to use. But when we look at it, we can see that it is nominal and it's got this K in here. Now, there are a couple of ways of dealing with these sorts of issues. One is we could manually clean them, which is an option. And sometimes if it's really just say one or two cases, hand cleaning might be a reasonable solution, particularly if you don't need this work to replicate. But often you can be working with hundreds or thousands or even millions of data points, and obviously those solutions won't scale. The other issue is that sometimes data is stored in a fashion or a manner in which it's not as accessible as we'd like. So here, test scores were joined based on not only the category of the test, but a student's score. Ideally, we'd like to split them up somehow. And if this were Excel, I'd say we should use string split or split on character. Unfortunately, we don't have that option in SPSS. And finally, the thing that I want you to also take notice of, and maybe let's sort this data so it's a little bit clearer, is that currently this data is in long format. And what that means is that each row corresponds to a single person's score on an exam. So we know that this student, say, let's sort just so we can see it a little bit clearly. Okay, so we can see that student one was in a medium class size. Their parents made roughly $62,000 per year. That student identified as male, and he got a 119 on the math assessment and a 93 on the reading assessment. And just the format of this data means certain comparisons that we might like to do aren't very accessible. That, for instance, if I wanted to see if math scores and reading scores are correlated, I cannot do that very easily. So I want you to keep that in mind when we restructure the data. So first, let's convert everything into the format that we want. One thing that I want to caution about, the thing that I am always tempted to see is, what if we just try and convert the variable of household income to numeric? What will happen? We basically lose everything. So we lose any data we have on household income. So we need to be very careful in how we do this manipulation. So let's reload the data and talk about how I think about doing these manipulations. With the household income case, let's look through and sort of see if there are any other cases we need to think about. Say individuals who don't have income, individuals who might have dollar signs. And it seems that we're okay. And the only case we need to manage right now is removing that K and converting things into a numeric. So how am I going to do that? I'm going to go through, take this household income variable. I'm going to look for a function that can replace the K. So what I'm going to look at is string manipulation and replace. So what I'm going to do is I'm going to tell it, look inside the household income variable. And you can read the documentation here. It's a little bit hard to into it, but they give you vignettes or little examples. And what I tend to do when I'm learning how to do something is I take this example and I just manipulate it slightly. Oh, that's code from a different project. We are going to go to household income. Then we're going to figure out what character we want to replace. In this case, it's going to be a K. And we're going to enclose that in quotation marks so that SPSS knows it's a string and not a variable named K. And then we need to assign a character to replace it. And this is something that is a little bit counterintuitive, but you can replace this K. You can't actually choose to delete a character, but what you can do is replace it with nothing, which in this case, we're gonna represent by 2 quote signs. And because there are 2 quote signs, there's nothing in the middle, and we're gonna get rid of things that way. Okay, and then we need to rename that variable, and we'll call it income alt. And the other thing you need to watch out for is that you need to specify a type when you do these transformations. So let's see what happens if we do this as a numeric variable. Okay, so we are going to generate income alt. Okay, we're going to get an error message. And that is telling us that we're trying to assign something as a number that's a string. So what we need to do first is convert this to a string variable. Okay, let's try that. Did that work? Yes, it did. But we're still not done yet. We need to convert this into a numeric variable. Now, there are 2 ways we can do this. One is we could do this programmatically. We could go through and say, create a variable called income numeric, and that will be equal to number, which if I'm looking at conversion, I'm going to specify it, income alt, and then I need to specify a type of data. What I'm going to call it is a float, which is represented as F5. This is probably a larger conversation, but there are many different ways to represent numbers, depending on how big they can be in computers. Sometimes you will want to store numbers as integers, meaning that there can't be any decimal places or parts. Other times you might want extra precision. This is particularly true for when you're measuring things in very small amounts or very large amounts. So for instance, particles per billion, and you might have other measurements that are different orders of magnitude. So thinking about these things, is important, but is outside of the scope of the class. But let's just see if when we convert to income numeric, if everything works okay. Oh, you know what I forgot to do? I forgot to change the variable type. And that's the other thing that I want to encourage you to watch out for, is that it's very easy to forget to change variables and change the variable type. So what we're going to do is we're going to transform this into a numeric variable. And then we're going to run that command again, and we'll see what happens. Click yes. And let's take a look at our data, income numeric. That looks good. So we can get rid of we can now get rid of our household income and our intermediate variables of income alt. And you can actually do all of this in one step, but I find it's very helpful to just sort of see each step broken out piece by piece. Now, the next thing that I want to talk about is how we're going to deal with this test score. So there are two things we'd want. One is we want to know what the category is, if it's a reading or math assessment. And the other thing we want to know is the associated test score. So we need to think of a way to split these two up. I think it's very helpful to not worry too much about the actual code or command, and first just think through with actual logic of what you want to do. So when I look at these examples, I see that reading underscore sum score underscore and math underscore sum score underscore, they both follow roughly the same pattern. And if I can just get rid of all of this at once, then I have the number at the very end. So I think that's how I'm going to try and find the number. And if I'm trying to figure out whether or not it's a math or a reading assessment, there are a couple of ways I can do this, but the thing that seems easiest to me is let's just check if the word math or reading is in the test score variable. So let's try that right now. I was just taking a quick look at my notes and the code that I wrote out earlier. What you can see here is I'm basically writing an if statement the same way you would in Excel. And the way I read this is if the character of, if inside the variable test score, if the word math occurs, then the test type is equal to math. And then I run the same command if the character index test score reading occurs, then the test type is equal to reading. Let's try and do this through the interactive tool. So what we're going to do is we're going to generate a variable called test type. And what we're going to do is we're going to go to our string function. We're going to look at test score. Actually, no, we're not going to, we are going to say test type is equal to math. And we're going to build our if statement here where character dot index. And then what variable are we looking at? Test score. What are we checking to see if it's equal to? Math. And then we're going to press continue. Let's see if that works. Great. It populated everything for math. Now, what's going to happen if we try and do that same thing for reading? Well, if we change our if statement to be reading and change our variable, so our declarations also be reading, we should be good. Let's take a look. That's great. The one thing that I still have to watch out for is that these if statements linger. So for instance, if I was going to create a new variable, say score income in thousands, and it's going to be equal to income numeric times 1,000. Oh, actually, we might need to convert this to scale as well. Again, when things are specified as nominal, you can't necessarily do all of the operations that you would think you can with numeric variables. Let's try this again. Income in thousands is equal to income numeric times 1,000. Oh, I know what I'm doing. I bet some of you have already realized it. I forgot to specify what the new type of variable is. I currently have it as a string. It needs to be numeric. And again, this is all part of the learning process, that these errors are going to continue to happen until you develop hundreds, if not thousands of hours of familiarity with the language. And even then, it'll still crop up in unexpected ways. Now let's try. Okay, so this is what I wanted to show you, is you see that this if statement is only populating the cases where the test type is reading. And it keeps that until we get rid of it. So let's get rid of that, because I don't think we're going to need it. I don't think we're going to need it right now. I'm going to copy and paste that text for a little bit later. But we can just get rid of and turn off these if statements by going to include all cases. Right. All right. Now we've got to do the hard part of getting rid of the reading underscore SS underscore. The way I would probably do this is just note that the last three numbers are always going to be numbers, and that everything before the first number we can get rid of. So what I'm going to do is I'm going to write a command called score. And what we're going to do is we are going to replace we're going to use the replace function, test score. What we're going to do is we're going to look at reading underscore SS underscore. That's what we want to get rid of. And we're going to make that empty string. Okay, let's see if that's working. Okay. So it sort of worked. What it's done is it's generated the score for our reading scores, but it's left us with this math underscore SS variable without the scores for the rest. So how could we fix this? Well, I think the easiest thing to do is to use that if statement we were talking about. So I'm going to go to include if cases satisfy a certain condition. So we're only going to create this new score variable for cases where reading is present in test score, right? Well, let's take a look there. Well, nothing changed. That makes sense. Because we didn't actually overwrite the values from when the test score was met. Okay. So we're turning the if statement on. We're getting rid of reading underscore sum score. Now let's see. Great. So now we have blanks in our math, but our reading is populated with the numbers we want. Now we're going to do the same thing. And all we're going to change is we're going to change this to be math. So we're only running our new computation for cases where the test score is a math score. And we're going to change this expression to be math underscore sum score underscore. Right. Now let's see. I think this should work. Great. And now we have our score variable and our test type. So now the only thing we need to do is convert. So that's numeric. Oh no, I made the wrong transformation. Let's fix that real quick. And as you can see, what I did was I accidentally overwrote a variable and I had no way to restore it. But because I actually, let's do this again. Because I actually have my command prompt, when I go and make test type numeric accidentally, which I just did, oh no, I can't replicate my work. But because I have this in a command log, all I need to do is go back up and run it, and it will generate that new variable for me. Sorry, I might need to actually delete the column. It will generate the variable for me. What was going on again is that I was trying to generate a string into a numeric column and the data was not cooperative. But now we've got our test type, our score. Now we're gonna go through reshaping the data. The way we're gonna do this, first we're gonna convert our score into numeric data. And the reason why we're doing this exercise is that I want to try and see how math and reading scores are related. And I can't easily go to correlation right now and look at how a student is doing given the same ID. So what we're going to do is we're going to try and get each row to represent a student. And math score and reading score will be will each be a variable or column in the data set. And the way we're going to do that is we're going to go to data, restructure. It's going to ask us to save. We're going to call this data. And then we have two choices. We can restructure selected variables into cases, or we can restructure selected cases into variables. And this is something that I need to look up regularly. But in this particular case, I tend to think, are we gaining columns or are we losing columns? And in this case, because we know we want a math score and a reading score as a separate variables, I'm going to go to restructure selected cases into variables. And then what we need to do is identify all of the things that are unique. We know that student ID is going to be a unique feature in our new data set. We know that class size isn't going to vary within students, so we're going to include that too. We know that students' gender isn't going to vary within what subtype of test they took. And then we need to specify our index variable, which is going to be the test type. And again, household income isn't going to change. And we don't really need these two variables, but let's see what happens. And this choice, I usually let things be sorted by the identifier. You don't need to do these things, but you don't need to, but I find it's a little bit helpful to see if there are any errors or mistakes if you know that the data is arranged sequentially. And we're going to group by the original variable. And we're going to finish. And we can see that we have our math score, our reading score, and the individual scale scores we've generated as two separate columns now. And so now what we can do is we can study the correlation very quickly. That instead of having to do some sort of offset, we can just go to score math, score reading. And we can see that, in fact, the correlation here was actually surprisingly low. In practice, if you were looking at real data, you would see that typically correlations on these two exams tend to actually be much higher than 0.7. And just to go through the significance test here, it's a value of 0.1, suggesting that there is not substantial correlation between the two, and that if we were doing this as a hypothesis test, we would fail to reject the null that there is no correlation between these two subjects. The one other thing that I want to highlight is that when we start to get into regression, there are going to be some data cleaning tricks that are going to be very helpful and very necessary. One of the things that I think we already ran into as groups when we were going over ANOVA is that when we want to do one-way ANOVA, sometimes we need to do manipulations of data to transform strings into things that that SPSS can easily understand. So for instance, if I wanted to see how reading scores vary by classroom size, I cannot list that as a factor right now. So how do we list it as a factor? Well, there are a couple of different ways we can do this. But what I tend to do is go to transform, and then there's an option called automatic recode. And that's called, and we can create a variable called class size, and let's call this class cat. And what we've done is we've transformed to create a new variable called class cat that labels things 1, 2, or 3. And that corresponds to the values large, medium, and small. And so then if we want to run our ANOVA test, we should be able to do it now. So look at reading scores. And class cat is our factor. And here we can see that there's a marginally significant, that if we use our threshold of P being less than or equal to 0.05, we would still fail to reject the null hypothesis. But it's very close. The other thing that I want to show you is that when we get to regression, that some things that you will want to do, we can, when we try and predict, say, income or test scores as a function of class category, when we run this, what it is going to do is treat class category as a variable that goes from 1 to 3. And so the model really doesn't understand the difference between a small class, a medium class, and a large class. And in fact, when we look at the labeling, you see that it goes large, medium, small. And this is only due to the luck of fate that alphabetically these ended up going in order. In fact, these numbers don't necessarily mean anything. What we would want to do if we wanted to look at class sizes is we'd want to generate dummy variables. And the way we do that is we'd go to transform, create dummy variables, and we go to class size. Then if we were to run this regression, we see that we have 3 individual dummy variables that we can include. This probably will be more of a topic for lecture, but when we include categorical variables, we need to leave one of the individual categories out, or else SPSS will do that for us. And that is because we're including a constant. So when we include large, medium, and small, it drops out large. And I'm not entirely sure of how SPSS decides which ones to drop out. I think it just drops out the first case in which it recognizes that all of the categories are listed. But in effect, what this means is that our reference category becomes a large class. So when we interpret a regression line, which we'll talk more about next week, is that you need to do a little bit of mental accounting to understand the effect of what class size means in this case. So for instance, A large class would just be equal to the constant, that on average they would have reading scores of around 99.7. A small class would actually have the sum of this equation, so that because a small class is not a medium class, this variable would be equal to 0. But because it's small, this variable would be equal to 1. So in effect, a small class would have a predicted reading score of around 101. I think this is a good stopping point. Check out the other lecture, the other solutions file, which I will send in an email right now. Thank you so much.